In Algebra 1, Section 7.1, we're dealing with the greatest common factors. So we're dealing with factors that numbers have in common. And first, before we can find what factors numbers have in common, we have to first learn how to factor. This is called prime factorization. So basically, I'm going to find the factors of each of these numbers to its prime. So prime numbers are numbers that can only be, the only factors they have is itself or 1, okay? So for example here, when we're factoring 12, 6 is not a prime. So I have to factor it more in order I get prime. So the prime numbers of 12 is 2 times 2 times 3. Well, since there's two 2's, it's 2 squared times 3. This is a prime factorization. For 60, it's 10 and 6 is a number, and you can choose any. I can do 10 and 6. I can do 30 times 2. I just have to keep going and then find all the the last branch in the tree that gives me the factors. So 5, 2, 3, and 2 are prime numbers. So then I can stop. But then 2 and 2, there's two 2's, so I do 2 squared times 3 times 5. This should still give me 60. If I multiply it out and give me a different number, then something went wrong. Okay? The greatest common factor is when you were dealing with two numbers, the biggest factor they have, the biggest factor they have in common is the one that that is the GFC, greatest common factor. Okay? So, for example, we're going to start with number 1, which is the prime factorization. Okay? So we're going to take 98 and we're going to factor it. Okay? So you might not know multiples of 98, but I know 98 is an even number. So I do know at least you can divide it by 2. And 98 divided by 2 is 49. So 2 times 49, right? And then 49 can be factored to 7 times 7. Well, if these are all prime numbers, then I can stop. So then it's 7 times 7 times 2, which is the same thing as saying 2 times 7 squared. And this is my prime factor. Now this, I'm going to do the same thing with 160. Now, the greatest common factor, again, does not have to be a prime number. So these all become factors. 10, 6, 5, 2, 3, and 2 are all factors of 60. Okay? So we have 100. And then we have 60. So we know that factors of 100 is 10 times 10. I don't have to go to the prime numbers, right? I don't have to go to the prime numbers because it needs to be a bigger number. Now, if a prime number is all they have in common, then I can go there. But let's start with the biggest, okay? So I don't have to keep factoring these out. Let me just find multiples. I have 10 times 10. I have 100 times 1, but I didn't put that in. I can do 4 times 25. I think that's it. 4 times 25. Oh, 50 times 2. 60. I can do 30 times 2. I can do 6 times 10. I can do 15 times 4. Can 100 be divided by 15? I don't think so. No, I should have known that. I can also do 3 times 20. And I know that 10 is 5 times 20. So it seems here that the biggest number they both have in common is 20. Okay? So it might take a little bit to do that. Sorry if that's confusing. But I'm just breaking it down to see what factors they have and find the biggest number that they have in common. Even though this has 30 and this has 50, the others doesn't have it, but 20, they both have it. All right? This one, we do the same thing. We're going to break it down. We're going to break it down and see what they have in common. So I have 15 times 15 is 3 times 5, right? And then I have 3 x's. And this is 9 is 3 times 3, and I have 2 x's. Okay? What do they have in common? Well, I know that they have at least 2 x's in common. So I can do x squared. They have 1 3 in common, so I can do 3. So their greatest common factor is 3 times x squared. So I think, actually, we can do the same thing with this. I don't know why I didn't think of this, because this is super confusing, and I don't want to confuse you even more. So let's try the same concept. Let's break it down to its prime and see what they have in common. That might be easier. So if I had 100, I know it's 50 times 2. I know this is 25 times 2, and this is 5 times 5. These are my primes. And I know 60 is 30 times 2, 15 times 2, 3 times 5. So these are the primes. So let's figure out, yeah, this works better. Sorry, I didn't think of that before. So let's find the primes that they have in common. They have 1, 2, so they have at least a 2, and look, they have another 2 in common, and they have another 5 in common, right? Yeah, so 2 times 2 is 4, times 5, look at that, same thing, without all of the hecticness, 20, right? So you can try the other way that I did, that's fine. I mean, it's not like I would have marked it wrong, but I think this one had a little bit more organization to it. So try it. Page 459, numbers 6, 11, and 14. 459, numbers 6, 11, 14, and I will see you in class.